Today we are going to discuss about factoring or factorization in algebra. So recently we know that what is a factorization in numbers. We know already that, for example, we have a number 60 here and we want to factorize into the prime factors. So what we do is start with 2. What we have is 30. Then again 30 divided by 2. We got an answer 15. And again into what? So we got answer 3. So when we factorize the 60 into this group of factors, so the answer is 2 times 2 times 5 times 3. 2 times 2 4, 4 times 5 20, 20 times 3 860. So this is how we are factorizing a number into a group of factors. So these numbers are called factors of 60. The number 60 has a factors of 2, 2, 5, 3. This is the way we write the factors. The same thing we can do it in the algebra expression also. So when we are in doing some algebraic expression solving, we need to solve some equations, so we need to solve some expressions. So due to that we need to factor the main expression in terms of their simple factors. That will help us to solve the equation. So this video I'm going to teach you how to factorize, how to factor these algebraic expressions. Okay, let's move. So let's start with the definition of factoring. So factoring in algebra is a process of breaking down an algebraic expression, especially a polynomial. You know, the polynomial is, what is meant by polynomial? Polynomial is a group of expression, group of terms. For example, see, x square plus 2x plus 3. This is a group of variables having a different coefficient, different power. See, this coefficient has the power 2, and this coefficient of x as a coefficient is 2. Then there is a power 1, then no need to write there. So here there is no variables. This group of this type of equations we call as a polynomial. So in coming forward we will discuss details about polynomial. So this time you just keep in mind this type of expression is called a polynomial. So as the definition says, factoring in algebra is a process of breaking down an algebraic expression into a product of similar expressions called factors. Same thing we found we saw in the case of a number. Here this is an equation, this is a polynomial expression. This expression we need to convert this, we need to we need to break down into a product of similar expressions called factors that when multiplied together gives the original expression. So when we convert or when we break down this expression into small factors, but when we multiply the factors we need to get the original form. This is called factoring an expression. Let's see an example here. See, it's like a reversing of expanding. See, what is expanding of expression here? Here you can see x plus 2 and x plus 3. So this are two products. So let's expand this thing. So what's x plus 2 into x minus 2? 6 minus 3. So x times x is x square. Then x times 3. So minus 3x. Then 2 times x plus 2x. Then this 2 times minus 3. So minus 6. So this one we need to simplify that one. Then x square minus x minus 6. So this is the expanded form of this expression. So this is called factor. These are the two factors of this expression. This is an original expression. Okay, let's see. This is an expression. It's a polynomial expression. Okay, what is the factor of this polynomial expression? This is it. So this is called expanding. This is called expanding two factors to getting an original expression. So what is factoring? Factoring means we have an polynomial expression like this. We need to factor it into product of two similar terms. So when factoring it, we got an answer of x plus 2 and x minus 3. This is the two factors of this polynomial expression. So you have a basic idea what is factoring and what is expanding. Expanding is we are expanding two factors by multiplying the each terms, and we are expanding into a polynomial expression. So factoring is the polynomial expression. We are going backward and we are converting that into breaking down it into smaller factors. Okay, so this is called factoring. So moving forward, we will see why we are doing this, why we are factoring it, what's the use of that. Okay, let's see. So before leaving, I just want to mention you factoring is a reverse process of expanding. Expanding is a reverse process of factoring. Okay, just keep in mind. Why is factoring important? See, the first reason is it simplifies the expression. Yeah, it's true. Look at here, x square minus x minus 6. Okay, we factor it into x plus 2 and x minus 3. See, look at this one we make it in a simpler form. Okay, we factor it and we make it in a simpler expression. This is the first use of factorization. So let's second one, solving polynomial equations. Polynomial equation, this is the one called polynomial equation. This helps us to solve the polynomial equations. So right now we are seeing the second degree polynomial. So if we go for a third degree, fourth degree, it's before solving it we need to factor it out. That will help us to find the solution for the expression. The third one is helps in simplifying fractions. When we go fraction, if we go for a bigger equation like 4x square plus x plus 3 divided by 4x cube plus x square plus 6x plus 3, when we have a bigger equation, bigger expression like this, by factoring out the numerator and denominator will help us to cancelling terms and solving it into a simpler form. Okay, then that will help us to simplify the fractions. So by analyzing the expression, we need to make the expression into a simplified form. That's a really required thing in solving mathematical problems, especially in algebra. Okay, so keep in mind this kind of factoring techniques will help us to simplify fractions and complex equations. The next thing is used in graphing quadratic equation, that we will see in the coming video because it's a little more complicated. So these are the some simple uses of factorization in algebra. Moving forward, we are going to see some common methods of factoring. So there are some methods used to factoring the polynomial expression into a simpler form. So let's start with the first method, factoring out of GCF. What is GCF? Greatest common factor. So greatest common factor, we need to factor out the largest common factor from all the terms. So while we see GCF, greatest common factor is nothing, it's just a simple thing. I'll show you. Let's just get an example like 6x square plus 9x. Let's see what is the common largest common factor here. So here is a x is here also x is here. So 6 is here, then 9. So what is the common factor for 6 and 9? It's C, 9, 3. 3 is a common factor for 6 and 9. So x square and x. What's the common factor? It's x. So here we are going to pull out 3x from each term. 3x from here and 3x from here. Let's see what remaining out. So first term will be 3x is out. Then what's the balance here? What 6, 2 into 3 is 6. So when I take 3 out, then its balance is 2x is the balance remains. So what remains here? Only 3 remains. So this is the, so let's see what we, the factors I made is correct or not. Just again expand this one. So 3x into 2x square is equal to 6x square plus 3x into 3. So 3 into 3, 9x. Correct. So this is, we convert this into the factors, then again expand, we got the same expression. So this is how we find greatest common factor and pull it out. So 3x is the greatest common factor for the both terms, so that 3x we pull it out, pull it out. Then what's the remaining here? 2x plus 3 remains. So this is the simplified form of, this is the two factors. 3x, one factor is 3x, the other factor is 2x plus 3. This is the two factors. This is how we use the GCF technique. Okay, let's go for the second one. This one you need to attention for this one, because there's two types. Factoring trinomials is same as quadratics. See, what is trinomial? We already heard that polynomial, then trinomial. See, trinomials are also polynomials, which has a term, only 3 terms. So see, x square plus 3x plus 4. How many terms it has? 1, 2, 3. These are called terms. So terms 3. So this type of polynomial we call it as trinomial, otherwise quadratics. Okay. So the other form we for example we have it is for x raised to the cube plus x square plus 3x plus 4. If this kind of equation we normally call as polynomial with a degree of 3. So that we will see in the next future videos. So the equation, the expression has only 3 terms, which has an order of x square plus 3x plus 4. I mean a x square plus bx plus c. In this form we call as trinomial or quadratic. Okay, come back to our factoring technique. So what is standard form? Standard form of a polynomial is ax square. So standard form of a quadratic is ax square plus bx plus c. This is the standard form. This kind of expression we call as quadratics or trinomial. Okay, so the first type is simple trinomial. Simple trinomial means the a should be 1. The value of a is always 1. Then always the coefficient of x square is 1. Same like this. See, x square. See, look at here. X square plus 5x plus 6. What is this? The x square, the value of a is 1. So we can call it as a simple trinomial or simple trinomial, simple quadratics. So factor number that multiplies c and to get b. So this is a technique we are used to. This is my own personal technique. This is my own personal way of doing this. So you can either you can choose follow this, or you can do your own. See what the statement saying: factor the number that multiply to get c and add to get b. There is two numbers. There is a two number which multiply the two number, we got an answer of 6, and when we add the two number we got an answer of 5. So we can see there is a two number that when we multiply the two number we need to get an answer of 6, and when we add both the number we need to get a value of 5. Which are those two numbers? Just think, you will get easily. The numbers are 3 and 2. 3 and 2. See, when we multiply 3 and 2 we got an answer of 6. When we add 3 and 2 we got an answer of 5. So that's very easy. We are simply we got the factor. So this is a positive 3 and positive 2. So we can write x plus 3 and x plus 2 are the factors of this quadratic equation or trinomial expression. So this is the first simple trinomial we can do like this. Okay, we can just we can just do a mind calculation. We can easily jump into this expression to this factors. So just go to complex trinomial. What's complex trinomial? A complex trinomial is A is not equal to 1. If A equal to 1, it's called as a simple trinomial. If A is not equal to 1, we call as a complex trinomial. So AC method of factoring trinomials. So here we going to take another type of, so AC method is something which is related to the first method, like the simple trinomial method. Here what we're going to do is, AC method is a reliable technique of factorizing trinomial in the form of ax squared plus bx plus c. But the condition is a is not equal to 1. It should be more than 1. So b is a middle term. This is the b is called the middle term. This one. This is called middle term. C is constant. This is a constant term. Constant means there is no x, y, no variable with this. So this is a symbol, a constant. So this is called a complex trinomial. So when we have a complex trinomial, what we want to do first, I will show you. See, this is an example. First, what we need to do is a, which a here, a is, b is 7 and c is 2. These are the values of coefficients. Okay, what we need to do is a times c. So what is a times c is equal to 6 times 2 is 12. So let's find a times c. Keep it here. Then the second step is find out two numbers. See, let's keep it here. Find out two numbers that multiply to get AC and add to get B. Means that there will be two numbers. See, two numbers, we don't know. These are two numbers. But when we multiply the two numbers, we need to get an answer of 12. Okay. But when we add those two numbers, you need to get b. What's b? B7. Which are the two numbers? Very easy to find. See, the numbers, we just make my way of writing. So when we multiply, we need to get 12. When we add, we need to get 7. So the numbers are 4 and 3. Got it? So 4 times 3 is equal to 12. 4 plus 3 is equal to 7. So we got the number. So we got the number is 12 and 7. Okay. So next, step 3 saying split the middle term using those two numbers. What is it? So split the middle term. So 6 square. So we can write this. We can rewrite the expression here. 6x square plus two numbers are 4 and 3. So 4x plus 3x plus 2. Okay, fine. Okay, so we got an expression like this. Then what next we need to do? Factor by grouping. Group the terms in pair. So what we're going to do is 6. Here we have 6 and we have 4. Then x and x. So what we're going to do is we are taking this 6x plus 4x. So from here I need to factor out 2x. Okay, I can factor out 2x. So let's factor out 2x from here. So what remains here? 3x. Then 2x I factor out. Then what's balance here? 3x plus, when I get 2x from here, what is this? This is 2 balance here because I got 2x from here. So balance is 2 here. So 3x plus 2. Then again plus, I'm just only factor this 2 first, then this 2 I make it separate here. Okay, so balance is what 3x plus 2. Wow, what is this? You can see that there is some common thing here, right? So when we have a expression like this, so we need to factor out again because both side has the common factor 3x plus 2 and 3x plus 2. So before that, what we're going to do is 3x out. So we need to factor out these common factors out. So I'm taking 3x plus 2 out from the both. So what's remaining in the left hand side? In this side, what's remaining? Only 2x is remaining. So we can just write 2 here, 2x. Okay, what's here remaining? because we already take 3x plus 2 from here. So here remaining only 1 because there is a 1 here. So plus 1 here. So finally we make this factor. We done it. We did it. So these are the factors of the expression, the great expression 6x square plus 7x plus 2. We factor out. The final factor is 3x plus 2 and 2x plus 1. These are the two factors of this given expression. So if you want to check, you can check, you can expand this, you will get the same expression here. Okay, what's the third one saying? Factor by grouping. Okay, factor by grouping. Factor by grouping normally we use in 4-term polynomial. This is a 4-term polynomial, means 1 2 1 2 3 4. There will be 4 terms, and we have two variable, but and different coefficients also have, because a this here, for this one a is a coefficient for the x, for the next side b is a coefficient for the x. So this one, this kind we can simply factor it out. So first what we do, factor a out. So a in the bracket x plus y plus, so what's the next one, b, we factored b out. It's a x plus y, same thing we did before. So here what's the common factor, common binomial factor is x plus y and x plus y. Then again we take the x plus y out. So x plus y outside. Then what's remaining here and here, a and b remaining. So when we out a plus b remains here. So this is how we group the common factors, and we group the factors out. So from this equation to this equation, so when this is a complex equation, when we factor it out, it will become the simplest form. So the fourth one is difference of squares. Difference of squares. What is difference of squares? This is the common general equation of difference of squares. See, a square minus b square. We can factor it out simply, a plus b and a minus b. So whenever you have an expression like this, a square minus b square, you can simply think and factor it out, a plus b and a minus b. Y is here. If you have any doubt, we can just expand this form. So a times a square, then a times minus b, minus ab, then b times a plus ab, then b times minus b. So plus and minus multiply, we got, okay fine. So plus and minus b square. So what we going to do is, now this is cancel each other. So what's the remaining here, a square minus b square. That's it. Very easy, very easy. So this is how we use difference of squares equation to use to factorize the things. Let's go for an example here. This one, keep in mind, this equation is very important for going forward. So let's go for an example here. Here see, here we can see that x square minus 16. So let's factorize. See, when we see an expression like this, we can say this within seconds. We need to come in your mind that it's an expression like this, x square minus 4 square. See, 16, what is 16? 16 is a perfect square of 4. So we can rewrite it as x square minus 4 square. So same this rule apply here. What is here? A square minus b square. So what is a and b here? A is x and b is 4. So we can simply write x plus 4 and x minus 4 is the factors of this expression. Same like here 9p square minus 1. So what is 9p square and 1? 1, one square is 1. So we can consider 1 as a perfect square. Here 9 also a perfect square. So 3 square is 9. P square. So we can rewrite this expression as 3p the whole square minus 1 square. 1 square, no need to put the square here because you already know that 1 is a perfect square. Then both a square minus b square times. So what we will write here, 3p plus 1, 3p minus 1. This is the factors of this equation. So using this difference of score equation, it's very easy to factor out when we see an expression like this, like a different square similar to this one was one, we can very easy to factor out. So keep this equation in your mind. Remember this when we're solving future equations. Okay, just move for the fifth one, perfect square trinomial. Perfect square trinomial, see what is perfect square trinomial? See, a plus b the whole square. From the childhood, from the school, on the basic school level, we know this two equation by heart. So a plus b the whole square is equal to a square plus 2ab plus b square. A minus b the whole square is equal to a square minus 2ab plus b square. So whenever you have an expression in your an expression like this, keep in mind this directly you can use this one. Okay, let's expand this thing. So this is x. What is this thing here? Here is 2ab, right? 2ab. So 2 times 1 times 3. This is 2ab. So here. So what is the x here? So what is a here? So a is equal to x and b is equal to 3. Okay, this a and this is b. So we can directly write this thing into x plus 3 the whole square. This is the factor. It has only one factor. So we can write directly the x plus 3 the whole square. This is how we use perfect square trinomial equation to find the factors of this trinomial equation. See, keep this equation in mind whenever you see an equation like this, when a expression like this, directly jump into this factor, the answer. Okay, so let's move to the next one, sum of difference of cubes. Same thing. Before we see the same equation, we can same apply it in the cube version. So a minus b a cube minus b cube is equal to a minus b times a square plus ab plus b square. So next is a cube plus b cube. We can say a plus b, a square minus ab plus b square. So this equation always keep in your mind to memorize. Try to memorize this one. So it will be very easy for you to solve the equation. See, if we find y cube, see, y cube plus 27, a expression like this. So how we will factorize this? We can see that what is y cube? So y cube plus 27. What is 27? 27 is called 3 cube. What is 3 cube? 3 cube is equal to 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. Yes, so 3 times. So we can directly apply this equation here. So what's the factors of, what's the factor of this? Directly we can write y plus 3 factor, then y square minus 3y plus 9. So see how we will suddenly how fast we find the factor of that equation, polynomial equation. See, using the sum or difference of cubes equations. Okay, let's see this one. So here x cube minus 8. So 8 we can write in the form of a cube. So x cube minus, what is 8? 2 cube. See, 2 times 2 times 2 is equal to 8. So we can write 2 cube. So then if we saw like this, suddenly you can it should become in your mind, what is it? Difference of cube. So directly we can write the equation here. What is this? X minus 2. Okay, then x square plus 2x plus 2 square. 2 square is 4. So this is the two factors of this one. So while we apply the sum or difference of cube equation to find the factors of these two expressions. Okay, so I think everybody understood this thing, because this is just nothing, just to memorize that one. When we saw that kind of expression, suddenly jump into the answer. Okay, So if any doubt, we will see the when we solve some problems, example problems, you will get to know more about this thing. Okay, then before going for the practice problem, there is some special patterns also to identify. See, when we have an expression, always keep an eye for pattern. We saw already some kind of patterns, see, difference of cube, difference of square, then this trinomial equation, simple trinomial, complex trinomial. We already know some kind of patterns. So while doing these problems, you will come to know, you will get more practice to solve problems quickly. So what we need to do is, first you need to keep your eyes open for finding some patterns here. See, here see x square minus 2xy plus y square, x square minus 2xy plus y square. What is this? It's the difference of square. So suddenly you write, when we find an equation like this, suddenly you need to write the factor x minus y whole square. Same thing here, x square plus 2xy plus y square. When you see an equation like this, what is this? What is this? This is just, suddenly you need to come in your mind that it's difference of square. So suddenly we can need to write x plus y the whole square. This is the factor. Okay, let's do the practice problem. What is it? This is not a simple trinomial. This is a complex trinomial. Why? Because a is not equal to 1, because here the coefficient of x z square is 2, so it's not a simple trinomial. So what, when we have a simple complex trinomial, what we need to do? Yes, we need to find the AC value. This is a is equal to 2, b is equal to 3, c is equal to minus 14. So what's AC? 2 into 14, so this is 28, so minus 28, so minus 28, okay? 2 into minus 14, so minus 28. Then what we do is, just see, my technique is like this. See, we need to find two numbers. You need to find two numbers. When that two numbers multiply, need to get an answer of minus 28. Okay, when we add the two numbers, we need to get an answer of 3. Okay, which are the two numbers here? Okay, you got it. I think you get more faster than me. The two numbers are minus 4 and 7. See, minus 4 plus 7. Let's answer minus 4 plus 7. It's 3. Then minus 4 times 7. What's it? Minus 28. Got it. So this is the two numbers. So what's the next? When we got a number, what we need to do next? Split the middle term. Yes, split the middle term with these two numbers here. 2z square plus 7z minus 4z minus 14. This expression. So here what we go, how we will group. So this is a common term. 2z square and 4z. Yeah, there is a common here. 2 we can factor out, and z also we can factor out. Here 7z and 14. So what we can factor, yeah, 7 and 14, so we can factor it out. So let's write it in the same order. So 2z square minus 4z plus 7z minus 14. So let's group out. We'll factor out this 2z out. So what's remaining here? Z minus 2 remains here. Then we factor out 7, so 7 is out. What's it? Minus z minus 2 out. Okay, yeah, again we need to group again. We need to factor out. So we're going to reach the answer. So z minus 2, z minus 2. So both sides z minus 2 is there. So z minus 2 factor out, and what's remaining here? Yeah, 2z plus 7. So this is the final answer of this equation. Okay, so what we do from the beginning, let's see from the beginning. So what we have an equation like this is not, it's complex trinomial. Then we need to, first we saw the AC, so minus 28. So then we need to find the two numbers which we got, which we got a number of 20 minus 28 when we multiply the two numbers. Then we got an answer of 3 when we add the two numbers. Okay, so the two numbers are minus 4 and 7. Split the middle term, this middle term into using the two numbers we got. So 7x 7c and 4z. Okay, okay. So we will, then we start our grouping stage. So we try to group and we to factor out common factor. Then finally we got an answer of this. Okay, so everyone, I hope everyone understood this one. Okay, our next example problem is this: factor minus 5v minus 445v plus 50. So we need to factorize down. Let's make it a simple factor. So first we are going to see there is three terms, 1, 2 and 3. There is some common factor here. It's 5 because 5, 45 and 50 are multiples of 5. So we just factor out, factor out minus 5. I am factoring out minus 5. Okay, so what is here? Balance v square is balance here. So I factor minus 5 here. So when I minus 5 here is 9. So plus 9 is the balance and v is remains here. Then I put minus 5 from here. So the answer is, the balance is minus 10. So how minus 10 comes is, see, minus 5 times minus 10 is equal to 50. Okay, so negative times negative is positive. So when we take minus 5 from here, the balance is minus 10. That's how the minus 10 come here. Okay, so now let's keep the minus 5 here. So just factorize this term inside the brackets. So v square plus 9v plus 10. Just same technique, the simple quadratic, I mean simple trinomial. Keep in mind this. When we multiply the two numbers, I need to get, and when we add the two numbers, I need to get an answer of 9. It's very, very, very simple. What is that? Minus 1 and 10. See, minus 1 and 10. This is the two numbers. So when we multiply, minus 1 times 10 is minus 10. Minus 1 plus 10 is 9. So this is very simple. So going forward, what we're going to write is minus 5 is outside. Okay, then what we write is v minus 1 into v plus 10 inside factor. Okay, so next thing what we're going to do is open the bracket. That's it. When we open the bracket, so is minus 5 v minus 1 v plus 10. This is it. So three factors, 1, 2, 3, three factors. This is the answer of this expression. So this is from the, here we use the common grouping techniques and the common factor out. Then we use the simple quadratic or simple trinomial to factor this out. So let's wind up. I hope everybody have a basic idea about the factorization technique.